Today we'll conclude this unit by looking at solving logarithmic and exponential equations algebraically. So our main goal for this section is to solve logarithmic and exponential equation algebraically rather than graphically. Just to recall, a logarithmic equation is an equation that contains the log of a variable. And the laws of logarithms may be used to solve logarithmic equations. So this is our main goal. Exponential and logarithmic equations can be solved algebraically. We will be referring regularly to the log laws as well as the exponential laws. So let's get started looking at the first. Let's get started by looking at a couple of review questions. Here is to simplify log, log 4 to 100 plus log 4 2. Now we need to simplify them, put them together into one log rather than adding them. So the first step, we're going to use the product law here. And using the product law, we will end up, remember your product law, we have a similar base here. So it'll be 100 multiplied by 2. So this will give us a log for 200. So simplifying it, the expression. Here we'll use the quotient law. In this case, we will have log 35 divided by 7. Simplify that. We have log 35 divided by 5. 7 will give us 5. Now remember, one of the log definition, log b to the bn is equal to n. Now, there's a power of 1 there. So if we use this definition, we'll end up with log 5 to the phi 1 is equal to 1. And remember the rule is that we could b to the n is equal to b to the n. If you were to write this on exponential, this would be b to the n is equal to b to the n. Or in this case, we have 5 to the 1 is equal to 5 to the 1. Just a little bit of review what we've done before. So let's look at a question. So here we want to solve this equation here. Let's say I give this equation. Just a review. We have log 2x plus log . Now, because these are like terms, we'll add like terms. So we log 2x plus log 2, it's giving me 2 log x. It's like if you have given x plus x equal 2, these two become 2x. So I'll do the same thing here, because they're like terms. So you have 2 log 2x, because you have 2 of them, equals 2. Next, I'll divide each side by 2, because you want to simplify it, right? So divide both sides by 2. So we have 2 log 2x equals 2, divided by 2. I'm left with log 2x equals 1. Now we're going to write this as exponential. So this is not necessary here because I have 2 equals sign, redundant. So now write as an exponential. So we have 2 to the power 1 is going to be equal to x. So we can say that x is equal to 2. So we conclude now. So x is equal to 2. So now there we go. We have solved the equation. So we have a log. We simplify by adding like terms and divide by 2. Then we change the log into an exponential to find a value for x. Now, to verify it, we will have to substitute the value for x into the log, which is 2. So replace x with 2. And the left side should be equal to the right side. So let's look at the left side here. We have the left side. Number written as ls is log, my left side here. Fuse this here. So this is my left side here. That's the right side. So the left side is log 2x plus log. I'll replace the x with 2. Now I substitute that, so we have log 2. So the x is 2 plus log 2 to the x. Now we know the right side here is equal to 2. So we want to make sure the left side is equal to 2, and then it will prove or test our answer. So notice log 2 to the 2 now will be equal to 1, because remember our rule here. We have, this is 1 here. Oh, replace this with 2 also. Remember log b to the b n is equal to n. I'm using the same principle here. So this becomes 2 to the 2 is 1 plus, and there's also 1, which is equal to 2. So the left side is equal to the right side. So left side is equal to right side. So 2 is equal to 2. We will be using this steps or this principle to solve algebraically log and exponential equations. Let's look at the first example. Here we're solving a logarithmic equation involving log b to dx. Here we have log 2x equal 5 plus 2x. So we have 5 is equal to log 2x plus log 2 to the 2x. Okay. So notice we're going to use the product law to simplify. So let's rewrite this as so we'll use product law of log. So by doing that, this becomes log 2, and then we have x multiplied by 2x. So 5 is equal to log 2 2x squared. Now we're going to write this as an exponential. So now it becomes 2 to the power of 5 is equal to 2x squared. So this is your base, that's your exponent, 2 to the power of 5, 2x squared. Now I will solve for x. Now, I can simplify this further by getting rid of the 2 by dividing both sides by 2. Now, just remember, this is basically 2 to the 2 to the power of 4, makes it easy to see, and becomes 2x squared. Now divide both sides by 2. It's equal to itself once. I'll just write over here now. We have 2 to the power of 4 is equal to x squared. Solve for x, I square root both sides. So we have x is equal to plus or minus square root of 16. So we have 2 to the power of 4 squared. That becomes so x is equal to plus or minus square root of 16, which is equal to plus or minus 4. So x is equal to plus or minus 4. Now notice, only one of this answer is valid, because a log is only defined for positive numbers. So we have a plus or minus. So now x is equal to 4. X equal negative 4 is called extraneous. It's a solution, but it's an extraneous one. So this would be your solution. Now we can go ahead and verify it, as what we did earlier in the first example, by substituting positive 4 for x and solve. Solve your right side, see if it's equal to the left side. Now I'll go ahead and I'll rewrite my 5 is equal to log. So here we're going to verify x equals 4 as the solution. So you have log 2x plus so let's work with the right side. So this is my right side. So right side is equal to log 2x plus So let x equals 4. So log 2 to the 4 plus log we are going to use again the log b to the bn equals n for all of these. So this could be written as log 2 square plus log 2. Now this is 8. So this could be written as 2 to the power 2 to the power 3. So we can rewrite as 2 log 2. Just 2. This becomes 2. This is 3. So 5. So we can conclude 5 is the right-hand side, and it's equal to the right-hand side, on the left-hand side. So 5 the right side equal to the left-hand side, so 5 equal to 5. That's verifying it. So go over the process again. Here you're given to solve for x, use the product law. We're going to put 5 log 2 to 2 x squared. Then you write an exponent and solve for x. There will be an extraneous solution. We discard it because you can only have a log that's positive number. So the negative we discard. And here we verify it by substituting 4 for x and solve. Okay, let's go on to example 2. There are 2 questions here. Solve 2 log x minus 2 minus log x plus 2 equal log 2 to 2x minus 3. Let's look at the first one, A. The first step you want to take is to consider the value, so consider values for x for which each one of these are defined. So log x, so x has to be greater than 0 because you have x has to be greater than 0. So for this one here, x has to be greater than 0. X has to be greater than negative 2. That's your defined. And here, 2x minus equal to 3. So x has to be greater than 3 over 2 or 1.5. So these are defined, x greater than 0. So x cannot be less than 1.5. So x, in other words, has to be greater than. For this to be defined, so x has to be greater than 1.5 for 2 log x for it to be defined. It cannot be less than 1.5. So that is our defined for the log. Next step, we'll go back and use our log to simplify now. We have 2. So we've established our. So now we have 2 log x minus log so using the laws of logs. And in this case, we are going to use the power. So here we're going to use the power to power law here. So power, so we have log x squared minus log now we are going to use the quotient law now. So we use the quotient law. We log, now putting this together. So we have x squared divided by x plus 2. This looks like it expresses a bit better here. This is log x squared. Now, this is equal to log. Now, by the way, these are all log base 10. When it's not written, these are all base 10 log. Now, we can change this, write these as exponents. Right, as exponents. As soon as we write as exponents now, we remove the logs. So now it becomes x squared over x plus 2 is equal to 2x minus 3. Then we will be solving for x. Now we need to solve for x. So we multiply both sides by x plus 2. So now we have x squared into x plus 2. Gives you 1. So we have x squared is equal to 2x minus 3. X plus 2. We simplify. So now simplify. And we end up with x squared is equal to 2x squared minus 4x plus 3x. So plus 4x minus 3x minus 6 will be plus x minus 6. So simplify further now, we'll have final answer of x squared plus x minus 6 equals 0. So we're going to factor this. So we have x squared plus x minus 6 equals 0. Factor this. Solve by factoring. xx, and that would be +3 here. This will be what, -2. So x is going to be equal to either -3, x equals 2. So this will be extraneous. So we say that's extraneous. This is our solution. And we can go ahead and prove it by looking at the left side and then the right side, and this should be equal to 2. The right side will be equal to the left side. In this case, you end up with 0 on both sides. Now, if we were to go through ahead and verify it, we'll substitute 2 into our log into x and x here. And you'll have to do, in this case, you have to do it for both sides. And you'll find that 0 will be equal to 0. So let's work that through. So we have our left side. We have 2 log x minus log x plus 2. So that x equals, so x is equal to 2. So we have 2 log 2 minus, so we have log, use your power law here. So we have log 2 to the 2's is 1 there, minus log no, it should be log 2 here. Okay, we're working in base 10. Sorry, that makes it much easier than I thought. So this will be 2, this will be 4. So this becomes 4. This becomes 4. So log 4 will give us 0 log 10. So 0. So log 4 minus 4 is equal to 0. Okay, so simpler. And the right side, we have log 2x minus 3. So we have log 2 into 2 minus 3, 4. So log of 1 is equal to 0, because you remember log 10 to the 1 will be equal to 0 here, right? Because 10 to the 0 is equal to 1. So now left side is equal to the right side. Okay, that's the first question. Now, I will leave question B for now, and I just would like to go on to solving exponential equations in this session. So we've completed solving logarithmic equations. Now, let's look at solving exponential equation algebraically. And here I have 3 example questions. Let's look at the first one. Solve each exponential equation algebraically, and the answer to the nearest hundreds. And this is where we're going to use the change of base formula. Okay, let's look at your, now I'll need my calculator. So we look at base 10. So we have 9x, 9 to the power x equals 50. So let's write this down. So we have a 9 to the power x equals 50, and we want to solve for that. First thing we want to do here is to take the log of base 9 for each side. And the reason for that is so we can use a change of base formula. So let's look at this here. We have 9 to the power x equals 50. So take the log of base 9. So if we do that, we have log of 9 950. By doing that, this here becomes x. Because we are applying log b to the bn is equal to n. So 9 to the 9x, so this, your x is your n. Now we're left with log 9 to the 50. Let's carry this. So x now, we can apply the change of base formula. So apply so this becomes log 50 over log 9. And this is where we need to use our calculator. Now log 50 press my log here, log button, log 50 divided by log 4, or log 9. Give you an answer of approximately 1.7804. Let's go on to B. In the question B, we have 2, 5x minus 2. First thing you want to do, you want to simplify by dividing both sides by 2. There's a common factor here. So we have divide by 2. This becomes 5x equal 50. Similarly, what we did here, we'll take a log of base 5. here we have a log of base 9. Look at their whole number 5. So take a log of base 5. So log base 5, we have 5 into x minus 2. All of this now, what's remaining is x minus 2. Next, we want to solve for x here, right? So we have solve for x. So we have what x is equal to log plus 2. Now we're going to apply the change of base formula to log 5 to the 50. So apply change of base. So we have log 50 over log 5 plus 2. Now log 50 over log 5, I need to go to my calculator here. Log 50 divided by log 5 gives me 2.43. So approximately 2.4306 plus 2. So x is approximately 4.4306. Now the final part, C. Let's go back to part C here. We have C, which is 2x plus 3 equals 6. Now, step 1, you want to take the common log. In other words, base 10 log of each side. So take log of each side. Become log, which is base 10, but we're not writing it here. 2 into x plus 3. X minus 1. Now, I'll use the power law. Okay, so use power law here. So you give me x plus 3 log 2. I wouldn't write the 10 there, with 2 cluttered. And then this is also the power law here, x minus 1 log 6. Now we're going to apply the distributive law. So we're going to use the distributive law in this case. So we have x times log 2 plus 3 log 2. So this will give me x times me log 2 plus 3 times log 2 is equal to, here we have x times log 6 minus log 6. It's really 1 log 6, but now I'll collect like terms. So when I'll put the x's on one side and 3 log 2 and minus log 6 on the other side. Okay. So this becomes, so it's 3 log 2. So I'll move this over here, and so we have 3 log 2, that become positive, equals x log 6 minus x log 2. Now I'll apply the power law here. Oh, so this would be the product law. We can apply, yes, we apply power law here. So it becomes log 2 to the power 3, so log 6. And here we will apply the product and the quotient law. So to simplify this, we can factor out the x, or refactor the x. So we have x into log 6 minus log 2. So factoring x, common factor. You see common factor here. And here we'll apply the product law. So here we apply the product law. So this gives me log. Now I can change it to 8 multiplied by 6. Okay. Here I'll find the quotient law. So x log 6 divided by 2. So we have log 6 is 48 is equal to x log 3. Simplify that. So x divide both sides by a log of 3. So we have log 48 divided by log 3. Now we need to go to our calculator. And that will give us what, log 48 divided by log 3. By the way, I'm using my common log. You can see there. I'm using my common law button on my calculator. And I have an answer of 3.5 3. So x is equal to 3.5 approximately 52. So we apply the power law. We've used collecting like terms. Then we use the power law again, and the product law and quotient law. And then change of base. Well, we didn't have to use it here because it's already done for us. We didn't have to use the change of base because we selected at the beginning the common log. So there was no need to change of base because we already selected the common log to begin with. So your task is to complete Check Your Understanding on pages 418. So your assignment would be check your understanding. Questions 1, 2, and 3 on pages 418 to 421. And also you should begin work on lesson 7. Example 5 booklet. That's your handing assignment for marks. Tomorrow we will review Check Your Understanding questions and some other questions from your exercises. So to recap, our goal today was mainly to solve log and exponential equation algebraically. We looked at solving the log equations and look for extraneous. We said if it's negative, we can have a negative number for a log. It is extraneous, and then we verify our solution. So we looked at 2 log, and finally we looked at solving exponential equations. And mostly we applied the power rule or the product rule and the quotient rule. So we applied all 3 of them and the change of base formula.